So we're working on the advent of code, problem 11. This is part 2, which is the next day for me, or if you're watching YouTube, it's instantly, you just click to the next video, so no time has lapsed. Okay, so where we left off, we had created some rules, basically, that we're going to be, a set of rules that we're going to be running over each grid to produce the new grid, the new seating arrangement. And then we know we can stop doing that when the arrangement we create is equal to the previous arrangement. So as I started to fall asleep last night, it suddenly struck me that that this is occupied and for occupied function is wrong. And the reason that it's wrong is because I conj the space out of the adjacent spaces, and then I see if there's 5, but of course there might be, there's 2 things wrong about it. One is if I conj it onto the adjacent spaces, then there could be, it itself might not be occupied, and that's a requirement. Wait, if a seat is occupied, yes, so it's a requirement that the seat specifically be occupied, so it has to be treated differently. So this is going to be a and we're going to do occupied seat space, and then the second part of this is that it's not equal to 5, it's 4 or more, and this is a thread first macro. Will it work as a thread last macro? Because I typically use those. Adjacent spaces will be the first thing, Yes, it will. And then it'll be the last thing in here, in which case it needs to be greater than or equal to 4. Right? And so this means with our changes, we should now, maybe I should start writing tests. I guess if I keep having to come back to this, we might end up having to write some tests, so I don't have to spend forever checking things, or at least, feeling good about it. Because what we can do here is we can pick one that should be true in here, at least as a SAN-AG check, and so we'd need to, in order to do that, we'd have to, I guess we could modify this and create our own. That's basically like creating a test. You know what? Here's what we'll do. We're gonna roll with it and see if we get it right, if we get the final solution right, and then if we don't, then we're gonna slow down and we're gonna write some tests for these, maybe, to make sure that we're all our little blocks of logic building up to the final one is correct. Let's reevaluate the entire file, because I'm worried maybe I've made changes that I didn't evaluate, which is a great way to really confuse yourself. There's an error about cite a ripple state handler. Prematurely ends 5.6. I don't know what that means. That's definitely new. I think this is the LSP thing, sort of causing issues. All right, so I think those are the last. I think there's only these 2 rules, because the other one was that a floor stays a floor, and I don't think there's anything new in code about that, because we just won't update that. So what we do need is to either flush out. Yeah, here we started a function to take a space and produce the new space. So this is going to basically take the location it's taking the, right now I have it taking the row ID and the column ID and the space, which isn't necessary, right? So it should really just be location to new space. And then we can do this. And this is just going to wrap our other 2, right? So it can't possibly be both. So it's going to be a cond, and it's going to be um, so it's if it's empty and the four are adjacent, and this needs to take the location in the grid. So obviously this function too will need to take the location in the grid. Excuse me. Then, and what do we do in this case? If it's empty, then we make it occupied. So what we want to return here, because we're taking the location in the grid. If we have the location for handing it in, then we have it. So we could just return. We should just be able to return the new answer, so which is occupied seat. And then our second condition, our second rule is it empty? And it, no, that's the one we already did. Is it occupied? And the four other occupied, and that's going to take the location on the grid. And if it's occupied and the four other occupied, then we return an empty seat. And then else, maybe we do need to do we need it, because it's always going to be a floor otherwise? I think so. There's only three, and the only thing that I'm stopping to consider is, well, we would never be handing in the location of an index out of bounds. I mean, we do have to consider those, but we wouldn't be passing those in. So the only other one is floor. Right, like because it would have to be one or the other. Is that true? Maybe there's states like, or I guess it just it could stay what it is. Would that be right? So if we're looking at so like let's say in the case that the seat itself is empty, but there's 5 other around it that are occupied, it wouldn't match the first one or the second one. It would match the third one, and so it'd stay what it is. If it's the floor, then it wouldn't be empty or occupied. It would immediately go to the next one. Yeah. So the next thing is to just hand back the currently existing space. So we could have passed in the shape and handed it back. We could also just do get it on location. That kind of keeps the function. It means it can take lesser. It can take this, everything uses the same arguments in all the condition branches, which has a nice symmetry to it. So let's kind of just try to test this. At least sanity check. And we'll do 0, 0 with an empty one and occupied seat. Okay, this is happening because we're counting nils, and now I'm back to not understanding the problem that's being asked, because oh no, I guess that's right. It's just like this never considers how it should behave on an empty one, but I'm saying that, like, I'm saying that the problem considers nils to be, or the problem is saying that if there's like a space adjacent, if there's no if there's no space adjacent to you, like in this corner one, it still counts the things around you, the spaces around you, as like part of the count. Um, or that's how the logic has to work. And because what would be the alternative? It would just be like, if if we don't have enough to count, then we're gonna automatically no, because there could be conflicting. Like you could be occupied, so you can't count it as both. Like if you're occupied, you wouldn't want to count these as 1, 2, 3 unoccupied. You would even have 4. You'd like a corner one to always have at least 4 unoccupied then in that logic. So it's like really, it feels really like actually not well described in terms of what the behavior should be, at least from the wording. But I mean, maybe the example itself. Again, let's just see. Let's see if this. I mean, the problem here is that I can't really write a test because I don't know I'm not sure yet what the actual behavior is that they want. I'm gonna have to infer based off of the examples, it feels like. But we're like very close to finishing this. It would be done by now if I wasn't sitting here and thinking out loud as much. And so basically what we want now is a function that takes, we want to maybe not even make a function first, because could this be a reduce, or is this going to be a recursive function? Because in a reduce, what I would start is like our grid states a log of grids, and then I would always pull the last, produce a new one and put it on it. Produce a new one, check it if it's the same, produce a new one, put it on in. I think that, because I prefer doing reduce over a recursive function if I can help it. It always fills in KV right now for some reason. So let's try that really quick. And we also want to like test this. So we need a way to parse our seating chart output txt that's on the right, the one that's got multiple states. Let's do that really quick. Oh, it's not going to autofill in because it's not anywhere in the text. Oh, we wrote a function for parsing, and somehow we made it private, or indicated it was private. Let's move that up to and I don't know if this is going to be exactly the same because this is assuming 1. So we probably want to, you know what, for right now, let's not try to make a new function. Let's just grab everything that we really need here and just use what we need. Oh, actually, I wanted that. Part of this will be right. Why did it? Yoink. Okay. Come on. Copy. There's a thing where like if you paste and then undo, it like removes what's in the register for copy, and I don't like the behavior. I wish it always just had the last thing you copied in there, because like I might do something and then want to paste after like I hit undo. So in this case, when it splits lines, what's going to be wrong about this is that if we get up to here, then we split, we're going to get an empty line. What we actually want to do is now split on this empty line. So what do I mean? There should be just a line that's an empty vector. Yeah, like right. Oh, you can't see where I'm pointing with my finger. Anyway, there's just a vector with a empty string in it, and we want to, I guess, basically group these together. So what am I trying to say? I'm trying to say that what we have is like this, A, B, yeah, and then like in between we've got just this. So basically, we want to now put A so it's in a vector of vectors. Actually, I'll add one more just so it's like, you know, AO. So we want AO in one and B in the other. And the way to do that is you would have to, so if I map over them, that won't help because that considers I could reduce. If you do a partition, yeah. Partition by takes a function, right? Yeah, and so we're gonna give it yeah, I guess, you know, just like this. This is like weird. Like if you're reading this code, it's gonna be awkward. I don't know how to make it less awkward though. What do I mean make it less awkward? If you use like interparse with a grammar, I think it's way less awkward. Because then you can attach like meaning to this. You know, you could be like, you know, if it's like a specification from a company and this is like the format they send you, then at the top of the grammar it says that, right? It's not just like some code with like random string parsings. Like, you know, there's, you know, it says like Xco grammar rules like for their paper, like for their inputs, and it, you know, it outlines and it has like a word for this. It's called like, you know, the line white space, and that way when you're talking to people you'd be like, yeah, you know, the line white space. And it's like if that's used a lot, you know, in your business, you can build up a language about that. Of course, I feel like in all honesty that never happens. You know, coders code, you code, you know, you don't like you probably just get it done rather than talk about it. But anyway, this looks correct because these are all in here. And then we also just want to remove those, right? So the next thing would be to remove that item from the list, which you would just, let's make this a thread last. And then remove because it's even weirder now. Okay. Weirder, but you know, it's correct. Great. So yeah, we need this. No, we need these last two lines, these parts of the pipeline to be here. And then I think I can eval up to this point. Yeah, you don't actually have to, you can like eval in the middle of a data pipeline up to that section of it, which is pretty great. I'm looking at the output at the bottom in case people look. The other thing I can do to show the output is So maybe because I didn't evaluate the whole thing. I don't understand this error. Was there two underscores there? Yeah. This isn't what I expected. Because our empty lines are still in there. What didn't I do? Oh, I probably could have done it both ways, but I assumed it had been mapped already, I think is the issue. I could have done it the other way, using without it being mapped, but when I wrote it, I was thinking it was mapped. Okay, so on the right here, center like inspect mode. It's pretty nice. I've seen some recent tooling that's better. I've seen recent tooling for like evaluating things durable that's better that I kind of want to check out. Can't remember the name of the project at the moment. But this is, I mean, because this is my editor, this is really nice, and it pretty much does everything I would expect. And it kind of fails on really big stuff, but so will probably the other tools. Okay. So now the trick is we're going to be doing all of this, but only inside of a map. And it's going to get grid. Oh, yeah. So we're going to be taking, because we're going to be mapping over each one, and they're going to be the input. So it's like the symbols. And we're just going to run this function, but only instead wait. Wrong number arguments passed to eval. This is weird. This shouldn't have a F before it and in. That F is my editor using a fancy symbol for function. It is just the hash before the parenthesis. I'm not using a variant of closure. This looks correct. So these are all our states. So example output. Let's just call it grids, I guess. Kind of using grids and seating charts. And they did the same thing in the problem statement. They called it both, which is not good. Pick one. Example output grids. I mean, I know why they're doing it. The problem is me doing it. And we'll make this a def for now because it's only one thing. Probably only ever need to do one thing. I mean, I won't need to call this multiple times. I'm guessing there won't be another example input that I can use this on. Okay, so this is our example output that we're expecting. And now what we need to do, I'm gonna pause the video and I'll be back in a second. All right, so we're back, or I'm back. And I think what we're doing right now is we want to take a grid and we want to create the next grid. I think I was thinking about looping over the grids, but moving from one grid to the next grid is the next small piece of thing we can do here. So basically, our grid is a vector of vectors. It could also be a single vector of elements. You can always flatten something and then use the indices with some math to do roughly the same thing. And typically that ends up being faster in a lot of cases. Just having a single vector of numbers is typically how a grid is collapsed. I think serialization makes that more, like being able to serialize that means your grid can be a lot smaller, because you can take a list of numbers and then be like, oh well, we're not including more data structures than we need to, and then serialization becomes better over that, which means it's smaller, which means it'll take up less space, which means you'll have a smaller bill, or the package will arrive sooner, or any number of things. So we don't need to worry about that here, so what we've chosen is fine, though later, maybe with our algorithm that we're going to have to do, we'll have to go that direction. And in this case, when we're moving from a grid to the next grid, we're definitely just creating a new grid and returning that. So this is going to be a straightforward reduce. And what we'd be taking in each grid is the... Did we make this function already? Because I remember we looped over... Didn't we like loop and loop over something? A reduce and then a reduce? I remember writing or worrying about reduce inside of reduce. Did this happen in my mind where I worried about this? Wouldn't loc adjacent is space empty, space empty. Oh, current to next? Yeah. It even sounds the same. What's this parenthesis? Okay. So current to next isn't as good, so I'm gonna steal the name I've started with here. I've even got a comment that says it's not done. We started doing this and then I realized we didn't have the smaller functions really built up to justify it. This if empty might not be necessary, but we're going to keep it for right now. I'll trust my past self that... I think that was maybe before I realized nil would work, and we wrote all our functions, so I think they would work on it. But we can also just return it here. We can also just check if it's empty and return it. That won't hurt anything. It's just more code than we need. Okay, so we're down here and we're working on the row, and we're saying we want to conj onto our new row and then we just put in our function that we made, loc and grid to new space. And it would be row. Well, what did we hand it? What's the arguments to this function that we made? It's location first. So row idx and call idx. We don't really need the space. It's redundant. This has to be reduced QE. I've also got a conj on the new grid, and then this gets past the grid. So in the inner one, we would be reducing over. This wouldn't be new grid. This would be new row. Wait. So if you're, this is why inner loops are always hard. So the outer loop we're going over the rows, and so we need to produce new rows. I've got new, well, no, because all the rows together would be a new grid, so that's correct. So it's definitely going to be kanji new grid onto whatever all of this is, so that's correct. And then this is probably not the best way to do this with the reduces, because look at these, I've got like items I'm not even using, because I don't think I need the row. Yeah, because I'm not going to, oh no, I do need the row, because that's what I should be iterating over. Maybe I shouldn't trust my past self. Let's see. Yeah, this is the initial, but this needs to be row, right? So this is this is our last argument in the reduce. No. Here, I should use this here. So this is our next argument. To the first reduce, the first argument is the function. The next one is now this is where I should be using the S expression manipulators for sure, because I want the first thing to be an empty vector and the next thing to be the row. Unresolved symbol. Why is that? This is the function I'm passing to reduce. Oh, because it's not available there. Because the first thing, let's clean this up really quick. I know what I want to do. It's like I'm having a hard time lining things up while thinking at the same time. So right now what am I reducing over? That's the first argument. And this is the initial collection, and I'm not reducing over anything. That's why it looks so funky. I think we were kind of like sketching this out last time, and I thought it was cleaner than it was. So now inside the function, inside reduce, that's our init. So when we get to the new grid, the function we're passing here, this is where our init, I would like it if it highlighted and told me that's F, that's init there. In the bottom of what I'm looking at, I'm talking about is in the bottom, it's like Emacs is telling me what variable I'm filling in. And so now here's the collection, and this is what row would be. We do need row, we don't need the individual space, because we're gonna refine that using the row IDX and the column IDX. And this is where if it was just a vector of numbers, it would be a little bit cleaner, because you wouldn't be like ignoring things, which always looks awkward to people. Why are you ignoring something you needed that you pulled out and reduce? We're not using row count. Why did we want row count? I don't know. I don't think it. I don't remember why we wanted row count. Let's get rid of it for now. Okay, so grid to next grid, and we'll give it the empty grid, which gives this back, but we have a condition for that. So what happens if we don't? What happens if we don't have a condition for it? It's a reduce over reduce, and it should be nothing. It should be nothing. So we shouldn't need it. Yeah. There was no reason for that. I think it was just me being paranoid. Me not realizing what was going to come next was going to be treat an empty vector as we wanted to. What about an empty vector? Empty vectors though. Great. That's perfect. It's tough getting, like, if these typically work, your life goes a lot smoother when, like, because it means you've like written the logic in a way that's respects the data structure. It's like high level. It's not as many edge cases. If these don't work, it doesn't mean your problem won't work on the inputs are given, but it means like later inputs or working with the code might be more difficult. Um, and let's just put like one thing in it. What's one thing? Empty. Occupied seat, which is what we would expect. This is good enough for me to like feel like, okay, it's worth running the code. Or I don't know what the next reasonable step would be other than running everything. I guess we could put one more thing in it. Empty and empty. Occupied, occupied. Occupied seat. Yeah, because there's 4 more. Was an occupied seat if you're occupied and 4 more occupied, you get up, which this certainly wouldn't be. So this is what I would expect. And we'll put a floor in there, too. Make sure somebody occupied the floor. Why would that happen? Oh, my function empty considers floor empty, doesn't it? So floor is empty. Because I didn't, this is one of those things where like I didn't know what the business meant. Like, so basically to do resolve is a floor seat next to you considered empty. Right? Because that's like the business rule here that I would need to go ask somebody. Because the way I remember reading the problem, it went either way. And now we're having this thing where like I have to use the code to understand the business problem, which is wrong, right? It's just wrong. Just don't do that. It's like, well, the coding it this way is easier, so that's what people wanted. What would be an example of this? I mean, obviously, floor shouldn't go to change. We know that, but we can short circuit this because what I mean is we can just check if it's floor. I mean, the empty thing is still, the empty function might not be wrong, but we'll have to be very clear about what we consider empty. Like, this doesn't count for the space you're checking, it only counts for your adjacent. Like, you can't use this on the space. Like, we'll have to think of a new word maybe, but what do you mean? Oh, because we didn't write that. I think this is now this else condition. Yeah. I think this will fix our problem, obviously. Yeah. It fixes our problem, but maybe not in the cleanest way. But though it might, it's like it's not horrible by any stretch, because there are certain things where like the order matters. It's just that, well, what I mean is that this last condition isn't good. Like, it's not, the order then matters of these conditions, but that's true anyway. Like, in the code, there's an order, but I would prefer it if there wasn't. You could switch them around. I guess the default always has an order, so that's not really true. Maybe it's just that I don't like the idea of a default. Because then when new things come in, maybe you hadn't considered them, they're going to the default. which isn't what you want. But I guess maybe that's like a input verification issue, not the function's responsibility. Okay, sorry. I'm talking a lot here, which isn't what I typically do, so it's causing me to lose track of what we did last. Oh, what we did last is we created a grid to next grid, which is like should solve the whole problem. Should be all we need to solve part one, which is this is way longer than my last problem. I feel like we're on like 2.5 hours. So anyway, what I want to do, I've got grid to next grid, so I would just be taking, let's see if we can loop here. So it would be like grid states. I'll call it grid log, because what we're going to do, I guess we can always just conj onto the grid log. If we loop no, that's not what we want to do. We need our initial state. Yeah, I'm just gonna write a function because it's easier, and the loop is an optimization. And we'll probably need to optimize it another way. So get grid log. So init grid. We're going to take an init grid, and we're going to get a grid log, which is going to contain all the states on our right here. The grid log will, and then we'll compare it to the output we parsed and see if they're the same. So the init grid, and what do we have to do here? We just we'll pass it the grid log too. Might be a way to. Well, the grid log is always going to be the same thing. So making them pass that is a mistake. So what we're going to do is create a double arity function. I forget how to copy a word just by itself, so I'm going to just select it. And grid, and then we're going to supply the initial grid log because it's not, we're not going to supply the initial grid log, we're going to supply the maybe we don't need to do this. Well, if it's a recursive function, you do, because it's empty. Because what I'm thinking about it is, what we're gonna be pulling the last state off to. No, I guess we wouldn't. We'd be taking that, creating the new one. Let's just start writing the code. Let's not do this double arity thing, because I'm getting caught up in my head. It'll become more obvious here in a second. So we want to call our function to get the new grid to next grid, init grid. And then we've got our next grid. And then we just want to conj that onto grid log. No, we don't. What we want to do is if last grid log, which we don't have, so we will need to pass that in, or have it if last grid log. done. But we need to, we're creating the new grid log, because here, if this condition is fulfilled, if the last one's equal to the new one, new grid log. Otherwise, calling this init grid log obviously is wrong. Now, what I need to do is call it grid to grid log. At least. I mean, maybe another name change would be better. And it's going to take instead of the grid, maybe it needs to take the grid log, which will have the init grid inside of it. Okay. This is just a typo, right? Yeah. Okay, so the thing I was wrestling with was, like, what are we passing into this? Does it the grid and the grid log? The grid log could always have the grid, and that was the answer. This is inside a comment block, which shouldn't be. And so now what we want to do is see if our example output, why isn't this autocomplete? Grids is equal to our, before we do that, let's grid to grid log, which isn't a correct name. It should be grid log to like finished grid log, I guess. Ugh. And then I'm gonna be right back because I gotta go do something. Okay, we're back. And what we need, I just stealing the code from my example earlier because we need, yeah. That's not what we wanted. It's not the expected output. Let's double check that this is what we wanted. Seating chart example. Yes, that's the one. That's the file. Just one in there. Grid to next grid log. Let's make this grid or grid. This won't change anything, but it makes me feel like I don't have to look at as much code in the context I care about. Okay, so this is clearly wrong. Everything is, there's only one row. Actually, no, there's multiple rows. Well, no, the grid log only returned, and it's not even the right number. So there's a couple things wrong here. Those are ways to use the debugger that are, workarounds. Like, I should be able to, I shouldn't have to like declare things as variables to debug them as much as I do, but space Emacs and the inbuilt the built-in debugger provided by Cider have some conflicting key bindings, and so there's some things in the debugger that like don't work as well as they should. And I just keep hoping somebody else will fix that issue, because it worries me that I feel like I'm the only one that complains about it. It makes me think I'm doing something wrong, because it's like, if I'm the only one complaining. But I've asked and no, it's just like it straight up doesn't work. I won't even show you the details, but like when you're in the debugger, if you hit like into or skip, it like does the space Emacs binding first, like whatever is, like the order of precedence isn't correct, and it triggers those instead of the debugger's ones, and so you're all of a sudden you're like pasting into the middle of the debug code, and then it's all like screwed up. So I've just like learned to ignore those ones. So I have to declare a variable, otherwise I'll have to like I'll have to debug this function. That's not true, actually. If I put debug on the grid to grid log, that wouldn't be true. So we already ran last, so this is a grid, which is a row, which should have a set of rows, which it does. These are all occupied now. Oh no, there's a floor. There's floors, so this is probably correct. Yeah, this is good. New grid log. Grid log on a grid log. That's clearly not right. You can just stop right there. What did I mean? I meant next grid. Okay, so many grids up here. I should just probably drop the word grid, because we're like in grid land, and so saying grid everywhere in grid land, it's like a Dr. Seuss book, and it's confusing. It's fun in Dr. Seuss, it's not fun in your code. Things are still not right in grid land. Let's just, if I can't take out the word grid though, I could go from grid log to log though. I can use the rename function. So let's just make this log. Oh, we can't make it next, because next is a closure function. Next grid and grid is better. Grid log. At least that cuts down in some logs. I mean, I'm just debugging this because there's probably some, like that other thing is just, some small thing that's wrong. next grid, occupied floor, and then we're kanjiing the log to get the new grid log, which would be correct. Should be a big long thing. And let's see if we can inspect this. This is what I mean. Yeah, P didn't work. I want to inspect it, but it tries to inject. And this is really distracting for anyone watching. Fuck. Sorry, excuse me. The debugger did a thing, and it's always really frustrating because the behavior just seems so bizarre. Now there's just a log floating in the middle of the code. Because it pasted it in. That's what I was talking about earlier. So many great things about Emacs. The cons are that there's so many things. So you have to take the good with the bad. And the bad is lots of authors and me not knowing how to resolve the differences in their code. So I'm just going to walk this one more time because I interrupted myself. That's got to be right. Log, and we want to conj it on. And we want to get the last one. And we get the next one. The next grid to next grid. I mean, so far this code is correct. Next grid. Clearly not going to be true, so it's going to be false. So new grid log. And then this one should be one with... Oh, what in the world? Okay. This my function that I'm calling here isn't the right one at the bottom. It was very close, but not quite. And that's why, I mean, the output I was looking at was just like, it's so bizarre, in my opinion. This would be great, wouldn't it? You just feel good about it. So is this, did we make these into symbols? Like, did we run the symbol thing over this? I forget. Okay. It's not true. And how is it not true? How would we like to see in what way it's not the same? Because seeing it might give us some insight. Like, we can look at the code, but we've been doing that for a while, and I feel good about it. But there's something wrong, and we don't know what it is. So really, we want to visually inspect both of these. And what would be the way to do that? Have each grid next to each other, print them out. Yeah, let's just do one at a time, because hopefully the issue this is where the symbols would be better, right? Because my words were better for thinking, but my the symbols are better for visual comparison. Is that true? Is it true? Yes. So we're going to build a function to put them back into symbols. So space to symbol. Well, is there a function that would just reverse these two? Be really not good to... So we're going to make a note here. These are things I wouldn't do in a normal coding challenge. I wouldn't like be making these notes because it's too small. Like, and you know, it's just like the same with me talking about stuff out loud. But you know, this comment is basically saying like these have a shared dependency. They should be kept in sync, and I'm not because I'm duplicating them. I guess we could. I mean, why not? This is all for fun. So let's just take a second and see if we can. So we would want to reverse, or you'd have the relationship goes both ways on a map. How would you reverse? Actually, what if we just because I wonder what reverse does on a hash map. I know it's not going to do the final thing we want, but I was thinking it might do damn near what we wanted, like just with one modification. That's a set, which is not what we want. But I think is it into, or do I just call hash map? It just gave us back the same thing. I thought it reversed them. What is it even doing here? It's like it mapped over them, but it didn't change anything. Oh, it reversed. It like hash maps are probably have a set order under a certain amount of elements in them. What do I mean? I mean like when you use a hash map data structure enclosure, I believe, or it would make sense for it to, under a certain amount of elements, not be using a hash map, just because I think like it's, I'll just say better to use another data structure under a certain amount of elements, which can cause some weird bugs because in fact it means the hash map is ordered when you, like the data structure that it really uses is ordered under a certain number of elements. I think like, I don't know, probably like, maybe it fluctuates with how much memory you give the system, but maybe not. Maybe it's set. But anyway, my point is that it has a reversible order. You just don't know what it is, nor should you rely on that behavior, because it might change, because it's probably an abstraction. And those are fine to change. You shouldn't rely on the underlying mechanisms. That's what an abstraction is. The ability not to have to rely on the underlying, or think about the underlying mechanisms. So anyway, reverse, not great. But basically, no, it would be a one, it would be a tuple. There's something else you can do here. I think this, I forget, it might like destructure them without me having to do it. So what's K? Why doesn't it like this? Oh, because now they're reused. Wait, that shouldn't be a def in. It shouldn't even be a def because that relies on on you evaluating both of them. And now you see, now this is like the fact that this function doesn't exist. Enclosure. Boy. Yeah. Okay. Right, I'm gonna take a break. Alright, so we're trying to figure out why our grid, how we're trying to figure out in what way our grids are different. And I was thinking about printing stuff out. That's one way that definitely might be useful. Another option is certain test suites might pinpoint what's wrong, but really, like the test suite at this point isn't what I want because there's really not there's not a long-lasting test here. Like I wouldn't put the example like it's gonna be it matters if it works on new input, not this test output. I mean, what I'm saying is that like I wouldn't write a test with this example checking to see if it's the same because that like proves what you know. As where what you need is your function to work on the certainty that your function works on new input. Like, I mean, so it like wouldn't be a good test because maybe there's a problem in your code, but that wouldn't like you just got lucky and it worked. And so I just don't think that would be a great test. But what we do want, deep inspect closure. Is there, you know what, I think there's just a, deep compare. This might be good enough. I think there's other ones that are good too. I think that so this should, according to our example over here, same one, same, different two, difference in Uno, different or unique in dose. Oh, this is just printing out what's above. Diff. Oh no, this is different too. It's because they're using these words different. So this is telling you the thing uno dos, and it's returning one because it's different, and it's returning only here different two. So this is what's different from, the first thing is what's different from number two, and then the second thing is what's different from number two, and then the third thing is what's the same in both. Okay. And we would just do this on our example output and our this guy. Oh, I was counting them and right before I started and hit go, and it told me that there's only 3 grids in our grid log. So as we're in the actual example is 6, so it stops early. Diff says it can't be found. I don't know why that would be. Man, this is hard to read. It's gonna be way too long. I'm gonna have to be scrolling up all day, aren't I? This is the problem with these diffing things. It's like the output is so big. It doesn't like know what specifically you want to look at. Let's break this down. Let's just take the first thing. And the first thing will be what's in the example. It's what's in the first thing that isn't in the second thing. The thing that's different in the first and the second. So nil, nil. So this would be a grid. I feel like this is totally not helping me. Because what I'm getting back is a vector nil, 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 and then it starts 2 vectors. Yeah, not helpful. Right. I think I haven't tried it, but I think we can use this deep diff library, and we'll see if that gives some help. And then we'll have to take a step back and just consider a new approach. But I kind of want to do this just because, I mean, this is a common problem, and like, you know, being able to inspect 2 data structures that are deeply nested and see the differences is a common issue, right? Visibility on your project. So depths, and we want to add some depths. And then we want to bring this guy in. And we'll have to restart a ripple. Ripple connection closed. Restarting a ripple with our new dependency. Evaluate our file. Get a nil. Run their example code, which should print things to our ripple, and it does. Oh, look at those colors. That's nice. And what is this telling us? I would assume red is bad. Oh, it has like a minus, so A plus 1. So A is 1. So in both of these, they both have an A, and A is in a light blue color. Then we plus the C. So it's like, what did the first thing get? What do we do to the first thing to get the second thing? You plus the C3 and you minus the B2. Yeah, you see, I like this plus, because now I just have to think about, like, the other one was like giving me the differences in a way that was harder to follow, and this one's not. Like, this is just, how would I modify the first one to get the second one? I'm guessing this diff has more options you can set, but I like this. So what do I want to see? I want to see what I would do to need. I don't want to see what I would do to my example. Output grids to get what I have. let's make this a variable right now because we're using it a lot. Oh, that's not what I want. Current output. And that would be grid to grid log. So what would we have to do to our example output to make it like the other one? First off, to stop calling it GERDs. Something to slow down Emacs so autocomplete isn't as easy. Oh, I see. I eval the entire file when I had to restart, but not, I didn't, things in the comments don't get evaled, so, which is what we want. So yellow is apparently when they're the same. What? I'm just gonna assume that's not an issue, it's just some sort of printing bug that happens. Maybe not because it's repeating. So this would end, because it's a vector of vectors here at the end, this would end 1, and now we're into 2. Oh my gosh, look how nice this is. So basically our problem is we've got empty seats. So this is what we would need to do to the example to make it the current output. Which is, you know what, let's do this again, because mentally that's the reverse of what we want. We want to make our current output like the example. This is one thing. How do you clear your REPL? Like that? Cool. Because if we've got something that long, I mean, I've definitely had REPL output that was from like a previous thing, and I was looking at it thinking it was my current one because I had scrolled up, or thought it was one that it wasn't, and then it's like, you know, there goes half an hour. Why didn't it? What's going on here? So let's just, okay, we can do this too. I'm just gonna, you know, put something in the REPL so that I'm not worried about it. Now R should be under this line. You know what I mean? This is a visual marker, like. So this is what we do to our current output to make the example one. So in our current one, we would need to subtract plus. So I'm guessing it's saying that the 1, 2, third item is, we would need to take out the occupied seat and add an empty seat. So we have occupied seats that should be empty seats. And how, the reason your seat became occupied is because there were 4 around it that weren't, that were empty. What was the previous state? 1, 2, 3. So in the first row, the third one. 1, 2, 3. It was occupied. It's occupied and it stayed occupied, which you would need to because there's only, I mean, we sort of knew it was going to be occupied because the second one and third one are the same. That's why it stopped. But it should have gone to empty. So we have an occupied that stayed occupied. It should have gone to empty. What are our rules for going to empty? Because they're wrong. For going empty, it's, I mean, it's right here. You get empty because you're occupied. And the 4 are occupied. And so we can look at this one right here. Oh, well no, we can look at the 2 around it. Floor and occupied. Floor would be unoccupied. That wouldn't be empty. And so we'd have to look at so this location, in fact, would be 0, 0, 1, 2, 2. Wrong. Well, it's not wrong. Location's not wrong. This is just like just trying to get visibility on this. And so I just want to see what the surrounding things are. And to do that, we would need loc to adjacent loc. Oh, we already have this as a function, and we didn't reuse it. Oh, no, because this would be loc to adjacent spaces. I don't need the grid too. I mean, this is kind of what we have to do because I feel pretty good about the code we've written. Like, I don't think going back and like staring at it without having more information would be useful. So I need like precise information, which is going to take a moment to get. I'm going to have to build tooling to get it. And spaces. And then we actually need to get the grid. That is the issue. And the grid here would be, the grid in question would be number 1 on the current output. It's not 0, it's the second one. These are the ones around it. And our issue is that we stayed occupied. We needed to go to empty. And our rule for going to empty is if you are occupied and 4 other are occupied. And this output doesn't tell us. Doesn't tell us the surrounding which one's which, but that doesn't matter. But we do need to see the location, the space in question. So we need and we'll just call this A. Okay, so the first thing we have to satisfy is that where's our S? Oh, it's up here. It's doing this thing where it's like putting it next to it. very not what I want. I'm sure some people wanted that. But I'm gonna go try to figure out how to turn it off. I'm sure it's an option. I'm sure there's an option to make it so that they stack all the bottom here, which is just better. I don't know why that would be the default. So number one, we're definitely occupied. The space is occupied, so that's our condition number one. The A, we need at least 4 or more to be occupied. Occupied. That's 4. So like nothing's like my code this is doing what I want. And the first one was the same. Like the first iteration of our code produced the right output according to the example, and the second one did not. And it highlighted this as a difference. But for the rule it gave me, as I understand it, this is correct. Because the seed is occupied, which is condition number one, and then 1, 2, 3, 4 others are occupied. So I don't understand. I've encoded the problem wrong. Or I've misunderstood. We have to go back back to the future. I closed that tab. And we specifically care about how if you go from empty to occupied. No. Yes, we care about how you go from empty to occupied. I keep saying it wrong. We care about how you go from occupied to empty. Occupied. And this right here, occupied, and 4 more seats are also occupied. The seat becomes empty. Wait. I mean, I haven't misunderstood the rule. Do I have a typo? Occupied seat, space. Because that is the code I have. It should go empty. See, this is what I mean by I wish the paste didn't. Because what I want to do is I just want to grab this bit. Because this is like our rule logic high level. And insert it into this block on this specific example and see what's wrong. Because I think it's just because I'm a little bit tired and something, my X is a Y or something, you know. It's like I'm looking past the issue. It's like probably really obvious to somebody watching. Okay, so this is true. So it should go empty, which means we go up a level. Wouldn't be equal to floor. This wouldn't trigger. Is empty. I guess what probably happens is it got short-circuited and it redid it as empty. Because if it got to here, it would have changed it. Well, we can just ask it that question, right? I don't need to copy the function. Load to new grid space. Locking grid. Occupied seat. Okay, so it definitely just short-circuited. So I'm gonna read the. This is probably like that thing earlier when I was like empty. I feel like it's overloaded, or I've overloaded it. That's probably what's happened here. You would think how it'd be wrong. Every space is space empty. I'm getting out of the debugger because this isn't actually the function that's under question. It is space empty. I've got an or here. Is it? It wouldn't be a floor because it's occupied. It wouldn't be nil, and it wouldn't be empty because empty is not the right word. It's empty seat. Son of a bitch. Well, I guess that wasn't too painful. I mean, that was probably 25 minutes. I mean, probably would have probably half an hour almost talking about this problem. But I think if I wasn't concentrating on the webcamming part, it would not be as long. So let's reevaluate the namespace. I mean the file. And then let's see if we get, scroll down to our bottom here, make another marker. Actually, let's try to clear the REPL. Clear REPL output. Find and clear REPL output. That sounds like what I want. Output cleared. Okay, good enough. Let's run this again. Oh, we need to reevaluate these guys because they're not in. They're in a comment block. Hopefully nothing. I don't know, there's a lot of green. I'm worried. Let's just do this too. This is maybe where I'm messing up, and having the test would be diving deeper into it, giving me better input, but I don't think so. I think this deep div tool is probably about as good as it's gonna get. I mean, I wish it was ignoring the things that are the same. I wonder if that's an option, because I don't really care about the things that are the same. Are we using deep div 2? On the rate it's talking about, we are. Okay, so let's just count up to it and just do a diff on that. So this is the first one. all of that is the first one. That seems like too many. No, this is 0. This is 1. And this is 2. It doesn't seem like our change happened. Do I have another thing where I'm not using the right word? I haven't committed to, like, am I returning empty? I want to look at my grid to next grid. No, I don't. New grid space. Empty seat. Am I ever doing anything other than empty seat? That should be here, here, and here. I don't understand. So now it's saying, oh, we should just go back and, it's the same problem. It didn't turn it empty, but, yeah, it's still not doing it. So there's something still wrong. Because I have in fact saved and updated and all that. Well, I mean, it wouldn't even have triggered this. I mean, that was an issue, but it wouldn't have triggered this because it's saying it's currently occupied. Oh, right. Occupied and 4 other are occupied. Is occupied. An empty seat. Location grid. It definitely goes into this one. It's an occupied seat, which is not equal to a floor. False. And this should also be false, but it's true. So it is empty, and Jason is empty. Gets triggered. Is space empty? Every conj space should be fine. And the function takes the space. It's floor, or it's nil, or it's an empty seat. And it is not, I mean, the space itself, is it empty? So maybe I must not understand every. The closure function empty. I must have must not be doing what I think. No, I don't want to inject a function. Debugger, please exit. Every even 246, yes. Every even 243. Let's just grab this line here, because this should be returning false because we're currently occupied. We're currently occupied, so there's no way it's empty, because none of those would be true. But it's going to return true. And now, what don't I understand? Because that looks right, and that looks right, and or looks right. Oh, what is this? It's a... This F here means I've put a hash in front of the parenthesis, and that makes it a function. And I guess it's it's calling it. So it's calling it with this function is space empty, and then it's returning a function, and functions are things, and things are truthy. Right? Like, I guess every is space empty, for instance, is going to be true. It's not. I don't know. That's weird behavior. I mean, regardless, it's just unexpected and not what we wanted, so. I'm sorry about that. That's really dumb. I wasn't even seeing that F there. False. Which is what we want. False is correct. Wouldn't it be great if there's nothing here? I don't know if this is a new thing of the clear ripple output. Actually, before we try that, let's just see if they're equal. Because that would be immediately gratifying without having us having to look. They're not. Oh, we didn't reevaluate. This is like, you know, the trade-off I've made here. Versus if I had set up tests, this sort of like, what's my current environment thing wouldn't be as confusing. And if it continues, like if I have to do this maybe even like 2 more times, I might stop and write a test. Just so I can have a reproducible testing environment, and I don't have to sit here and think like, oh, I've got to reevaluate these things. Null pointer exception. Okay, I'm sorry, I need to look at the error. Just give it again. This is a really ugly error. Compiler exception. Well, that is, I mean, not something I want to worry about, but I have to. I mean, I know it's not the compiler's fault. I'm just saying it doesn't really narrow it down. What's the nearest thing I call? Like, is there anything here that references my code? I mean, I could Google this error, but I feel like it's not going to be helpful. I mean, we know what caused that. We know what, like, triggered the code problem. I had expected to get, like, a thing where it kept looping. Maybe, like, because now it never got a complete state because of another bug. That's weird because this completes. Why would... I'm really confused because now that I think about it, like my immediate reaction is always like, I've done something wrong. And in this case, example output grids is fine, right? Like we've already evaluated that. It's not, I mean, it's not lazy. And then, so that is a data structure and we're fine. And then current output is also fine. And then what's throwing an error then is nothing. I don't know what just happened. I mean, I'll watch the video, but like I feel like I evaluated this a moment ago and it threw an error. And now it doesn't, and I changed nothing. That's not true. Maybe I cider eval the file again in between there. And maybe something was an old state. Like I hadn't evaluated the function to pick up the new definition of is empty. Sure, maybe that's the case. What did this say though? False. So we're not out. It's tough. Nil. I want to clear the rep output though. I just don't want anything in there. Okay, good. So this is the third one again, right? Let's just get the third one of each of these. It's not the third one, it's the 0, 1, 2. Just focus on these guys. What are you doing? Parenthesis, slurp, go over here, add a 2, 0, 1, 2, yeah. Open, then clear the, it's a lazy sequence. Now this feels better because now I'm not secretly worried that I'm looking at the wrong starting one. Because if we do 1 and 1, right, these are the same. Yeah, this is all green. And then this is not. It feels like we have the same issue. It's an we have, and what we have is occupied, and what we needed to have is empty, and the previous one was occupied. And excuse me. The space is not empty. Every space is not empty. Why are we testing that? Because that tells us this isn't actually the question we want to have answered. Because we don't care if everyone's empty. We care if 4 or more. No. It is everyone is empty, right? What was the business rule? A seat is empty if there are no occupied seats adjacent to it becomes occupied. That's fine. A seat is occupied and 4 or more seats are also occupied. The seat becomes empty. So we want occupied to empty, and that's not happening. We want occupied to empty. We want occupied to empty to trigger. So we want this to trigger. So we get past is empty and adjacent is empty, which is correct. And then this should return true, but it's gonna return false. It returns empty, which means that which means I'm gonna take a break. But I'm sure it's just in here. Like, I've created I'm kanjiing incorrectly or something, right? Because what we just learned is that this returned empty seed, and so this should have been empty seed. Actually, no, this is 0, 1 now. So we weren't looking at the right one. Nope. I'm sorry. It's all the way up here. 0, 1, 2. So this is correct. 2 is the 0, 2 is correct. So it should have returned empty. It did return empty. On 1, which is what we're comparing. No, we're comparing 2, which is going to be the same though. It does return empty seed. And 1 returns empty seed. What in the world? Oh, okay. Well, here we're back to that error that I couldn't figure out. We didn't get a clean current output. Our grid to grid log isn't working now. But I'm gonna take a break. Back, I forgot to hit go. But basically, I forgot to hit go. I've been typing for like 30 seconds here. Basically what I found out in that little minute there was that the second input trying to go to the third, the second grid trying to go to the third is throwing a null pointer exception, which was that long stack trace that I was worried about. At the bottom it said null pointer. And that's obvious in the REPL. It just printed the null pointer. I don't know why it was printing all the stuff about the compiler. I feel like I had I go look at my settings Emacs to make sure I can turn off like filter to only stuff relevant to my project, because I don't want to get notified. But it's very unlikely that it'll be a compiler issue really that I'll be able to fix, and it's I just want to see like the return value that's more specific to my project. So what I want to do here is just debug grid to next grid on the second to the third, because that's returning a nil. So something in here is going to blow up. Even if I can just kind of sort of see where, you know, like just sort of space through here and like something's gonna explode. Not sure, maybe I could hit like trace. Okay, so it exploded just kanjiing onto the new row. That didn't happen very long, so we're gonna go through it again. And we're gonna go a little bit slower, so we can see exactly when it happens. There's probably a way to set a breakpoint at just gonna keep track of the row IDs. 0, 5. 0, 6. 0, 6. So it threw an error at 0, 6. Why would that happen? And we should just be able to like check that right here, like without anything else. 0, 6 has an issue. And this thing at the bottom, format specifier, doesn't match argument type. And then I don't think that's relevant to us. Okay, so let's look at the function we're calling. How did this even throw an error? We'll find out. Not obviously not here. It's going to be one of the inner functions. Nothing in here should throw an error. That's not true. So that's false. I didn't throw an error. Is occupy through an error? Again, I should figure out why I need to do this in my debugger, but I really don't think it ends up being that much different. 0, 6. I was assuming for some reason that I'd always be able to call that I'd always be able to there'd always be an occupied space because it's a thread last, so the it's using the keyword as the function rather than the map. And that means okay, so I just need to provide a default argument because if there's none there, it's 0. And so the error was that that the machine was complaining about is that you can't compare nil to 4 because it doesn't know what you mean. It's not true that it should just be 0, right? Like that's your choice. It can't make that decision for you, and when a computer can't make a decision for you, it shouldn't, and it blows up, which is correct for it, and the behavior is correct. And so I just needed to make a choice and tell it, what do I mean by nil? I mean, maybe a safe way to handle this is not, because you now, there's two ways to do this. You can have like a case statement instead of a hash map, and that sort of encodes the logic in one place, like meaning now when you're making those decisions and you get nil, it's like that is localized, and maybe that's slightly better. The alternative is that you can use the hash map, and then um, then you have to use a get somewhere else. You know, it's tomatoes really, because it's pretty they're close to each other, and it's not always the case that maybe you want it to be 0, and in the right now it's local, like that logic is localized to the function that cares about it, so it matters. If this sort of thing where like we need it to be treated as 0 was spread everywhere, then you'd want to like create a case statement for it and probably move away from the hash map, or reuse those things, you know. Okay, so the other thing is, now this is the first argument, so we probably just introduced another error if we don't pay attention, because now it's going to be here, and we need to be on the other side, because we need to be greater than equal to, right? Because it's going to come in like this, and we want this to be true, which obviously it's going to be. But yeah, when you flip these around, you gotta look at your pipeline carefully. Make sure you don't do something. I mean, throwing an error is okay, but the worst is it doesn't throw an error, and you're like, why? Yeah, is my output wrong? All of this will not work. It does. It reevaluated. Still not the same, but at least this will be. Let's reevaluate the entire file. This is yeah, when you start building up these projects and reusing lots of functions, you lose like the quick REPL local eval functionality, because you've got to reval if you've used the function. If you like change your function and then you update its definition, you also need to update the other functions where it's being called, because they still have the old reference, and that is a really good way to lose sleep, is to think that you have but you haven't. I'm printing a thing I don't need to print anymore. I was momentarily printing the counts. Don't need to do that. So apparently now these are equal. 2 and 2 are equal, so we've moved up the chain, which is really weird that it would get to 2 but not that we would be able to get 2 of them right but not all of them. I feel like it would be, yeah, so 2's right, and again, I could write like a loop here, but there's only 6 of them, so I'm just gonna manually change it. It's like more static, so there's less chance of me fudging something and then having to debug that and just changing these to 3. 3 is also true, so we get to the next one, and there's only 6, so, and this 4 is true. I wonder if true. This is really weird. I'm gonna take a break and we're gonna look at what's different about why would we get a no pointer exception on 5. So we get an out of bounds exception error when we try to get we try to compare the current output, the 6th grid, to the example 6th grid. And I think that just means that we're getting a index error out of bounds. Why would we get, oh, because there isn't 6. Right? Which one doesn't have 6? Do they both not have 6? What's the count on these? Current output 7. So our current output has one more than the example. I'm going to do a range here, just to double check. 0 through 6. So this should be 4. I need a for loop. I just want to see which one of these are different. Again, a test suite would, handle this if it deserved to be a test, but I don't think it does. 0 through 6, is it because it shouldn't be inexplicable? True, these are all true. And then the second we try to access 7. So it goes one more. Maybe I'm not stopping early enough. How would that be? Why would we do one more? Because they're all the same, which means it should have finished at the same time. Because if the ones before were the same, that means that 6 and 5 would have been the same. So hold on. So it means that 6 and 5 would have been the same. In which case, why wouldn't it have exited? Right? Because what we're saying is that up till these are all true, and if they're all the same, this should be up to 7. This might be where the mistake is, so range should be up to 7 because it's going to stop at 6. Right? Range goes 0 through 6. Why would there be an index out of bounds? I don't understand. The smaller one is the current example, and you should be able to call 6 on that. So this would be 0, 1, 2. So why would this be throwing an index out of bounds? Because this wouldn't throw an index out of bounds. Oh, because the count is always 1 less than the index. I was thinking about this wrong. So there's only actually right. Because the count being 6 means that there's really only 5 indices. Duh. dog is doing a thing.